All right, good evening, calculus students. We got a limit problem to deal with today, and it has some infinite discontinuities. All right, so for the function a whose graph is shown, state the following, and it says four limits here, and then it has the equations of the vertical asymptotes. And again, this isn't from Stewart. It's problem 8 from section 1.5. All right, so it starts with the limit of the function as x approaches -3. The negative is in front, so it's -3. Now that means the left, no symbol right here, no symbol right there. So that means the left hand and the right hand have to be checked. So I always start with the left hand. So I'm coming up the curve. That's my left hand. And I'm using a new program. I'm not great at the writing. And I go up here and I'm traveling up the curve here on the right hand, and they're both going up, and you can tell that they're going up to positive infinity. So this is a infinite situation. I'll go equals, and since the left hand and the right hand are both positive infinity, I can say it's equal to positive infinity. And the last question here is the equation of vertical asymptote. So boom, right away as I go here, boom, that is a vertical asymptote. It approaches infinity on either hand. You know it's an asymptote. So -3 is an asymptote. All right, we're going to probably find some more, so I'll put a comma there. Next one, letter B, limit as x approaches +2 from the left-hand side, the negative side. So here's +2, and again, I can tell pretty quickly that's an asymptote. So we're going to put the 2 in, and it's going to be from the left-hand side. So I'm traveling the negative side going down the curve, right, the left-hand side. And again, let's be clear, the right-hand side would be right up here, right? This would be the right-hand side in red, but we're in the left-hand side, so we're doing the blue. And as we travel down here, okay, we can keep on going. So then we see it goes down to -infinity. And I do this. All right. Then it automatically, and I'm going to change font colors because the next one is, hey, limit as x approaches 2 from the right-hand side of the function a of x. Well, we just said it's going right here. That is positive infinity. Now, let's be clear. The limit at 2, because these are not the same, doesn't exist. The left hand, letter B, and the right hand, letter C, do not match. Last one is to go back to the last asymptote. I'll change the pen color back to blue. It says the limit as x approaches -1. No hand after, no symbol, no plus minus after the -1. So it's -1 right here. And again, you can probably tell if I draw it in, that's an asymptote. So let's go to the last problem and put in negative, that's a comma. Let's put -1 in. And it's going, both are going down. The left hand on this side, the left hand's going down. The right hand's going down. So these are both going to -infinity. So you can say the limit's going to -infinity. Again, with both hands. And away we go. Now, I did one other thing here today. I put my own problem over here, letter F. And the asymptotes are -3, 2, and -1. You can see the vertical asymptotes. -3. I'll draw the vertical line in here. -1, and then 2. You can see that the hands aren't the same, but it's a vertical asymptote. So again, these are the 3 vertical asymptotes. All right. The last one I wrote today was limit as x approaches +3 of the function a of x. And I did this just to prove a point that if you come to, here's 3 right here, when you draw it in, this is not very interesting because the function is continuous. And when you have a continuous function, right, the left hand approaches that value, the right hand approaches that value. I'm going to write this time. It's actually equal because it's continuous, a of 3. Now, this time, what is a of 3? Well, a of 3 is 0. And I could do that anywhere, right? Whether I'm doing it at 6, 7, -3.5, whatever. But the point is limits are used typically where there's either a removable, a jump, or an infinite discontinuity. Keep practicing.